Hello, guys. Good morning from Justified Code. Today, our talk is about a problem faced by most systems. Typically, a system starts with a single front-end application. Let's take a desktop UI. It has a back-end service it communicates with, and this back-end service depends on some kind of a persistent storage there. We have a front-end team. We are calling it team A, and a back-end team B. Life is good. All changes incoming or requested by front-end team is happily served by the back-end team. Time goes by. The system is delivered on time. The system goes live. Customer is happy. Client, your vendor or the paying customer for your software company, is also glad dealing with you. What happened next is that the client comes in and asks for an additional front-end application to be added. We already have the web front-end handled by Team A. We still have the back-end service here handled by its own back-end team. Now a new team, we are calling it Team C, started developing the mobile app interface. This newly added interface has its own features. What happens next? Probably in the beginning, iOS team or the mobile team can consume the same backend service consumed by the desktop UI. But later on, sprint after sprint, they will start asking for for specific tweaks corresponding or related to the mobile screen constraints. We are talking here about screen size constraint or difference between desktop and mobile. Also, different features, different network bandwidth limitation. Probably he want to use the mobile application while he's driving inside the tunnel. What happened next is that Team B becomes frustrated, guys. Why? Because now he has to serve several teams, each with its own or distinct requirements. Having a single backend service would lead to conditional logic, adding if else depending on the browser agent incoming, leading to the catastrophe in code maintainability issues most of us are aware of. Imagine a mobile application asking for a shorter JSON response. that meets its screen or specific screen display that usually has a long grid displaying all the information inside the web UI, whereas mobile app has some different style display with few items. So from a performance perspective or bandwidth optimization perspective, why sending a fully blown JSON that is currently consumed by the web UI, by the desktop UI, why sending it as well to the mobile device? Sending data that the mobile app screen doesn't need doesn't make sense as well. So we have two problems here. The optimization part to serve mobile app specific constraints, specifically on the data bandwidth or data exchange format or size as well. The second one is the team dynamics, the team hierarchy affects such situation. You don't want your backend team to serve several front-end applications. You want them to stay focused on your business domain, on your business rules, the reason why your system was created in the first hand. Your business rules are the one that makes you money, guys. And usually they sit on the back end, not on the front end. All right. You ask, what is the solution for this situation? Several solutions were tried over the years. One of them is a backend for front-end pattern. This solution has several benefits. You see now, backend service isn't directly connected to the front-end devices. Or in other words, front-end application, the desktop UI, has its own web layer. Mobile applications have its own mobile layer. Team B is solely focused on the business rules. Team A now is responsible to handle the web desktop as well as this additional layer. Now Team C, the mobile team, also is responsible for developing the iOS application, for instance, and that mobile backend layer. Whatever changes required to serve the mobile screen is done at this layer. Team B, backend team, isn't concerned anymore unless there is a specific, very specific implementation that can benefit both front-end application. And this usually happens through Teams discussion. Now the mobile application needs a shorter JSON. Let's say the backend service has accounts array returning list of summary of accounts that can have a size of probably, let's say, 2 kilobyte, the web frontend is happily consuming that same 2 KB, whereas the mobile application can get this, sorry, the mobile layer, the mobile backend for frontend can get this and then do the necessary formatting or trimming and send only 1 KB response. I'm giving the numbers just for an example. It can be larger than that. Probably sometimes it may reach 1 mega for the desktop UI and 100K for the mobile. You want different compression algorithm? Fine, Team C can implement its own for the mobile additional backend for front end added. You want different language? Probably the programming language of the backend service doesn't serve the front end for any specific reason. Write it in your own language. That's Conway law, guys, applied in action. Now the structure of your team is dictating your architecture decisions. Always follow the structure of your team, the way your team is organized, the way your team communicates is the best way to know how to decide on architecture matters. No more request incoming from a mobile team now, the team C, for instance, affecting the backend team. Backend team has its own sprint, its own backlog, its own Kanban board, I don't know, their own Scrum framework, their own life cycle. Team A has the same. All right, there could be some cross communication when need be. But the idea now, again, your team structure has affected or can guide you to take the best or a better decision. Remember, there is no best decision in architecture. There are only better decisions. Teams are happier and your front end devices also feels happier. I don't know if we can say that. Now, let's go to a specific case I usually face. Okay, we have an iOS application. We have now an Android application. Probably an additional device, but these are the main brands nowadays. Now the decision come into play whether to have a specific backend layer for iOS and another one for Android. Let's see what could be a better decision here, depending or relying on what we spoke about previously now on Conway law. So you have two options here. You either keep one mobile backend for front end versus having a backend for front end for each front end application. The beacon or the guide, the main criteria that affect my decision is again your team structure. Again, Team B is handling the backend. He has its own sprints, his own backlog. Now, if the same team is handling both iOS and Android application, then yes, go for a single mobile backend for frontend. However, if Android team has its own team D and team C, sorry for messing up, is handling iOS application, then definitely go for a single BFF for each, a distinct BFF for each device. I think you know the reason why. You don't want both teams to affect each other on the back-end side. Each feature can be served by its own team. Team coordinates with each other only when necessary. That is productivity, guys, and that is another example where Conway laws is applied, where your team structure is dictating your architecture decisions. Team A has nothing to do with what's happening here, happily serving its desktop UI client. Another use case I faced. We had a bank, or let's call it a fintech application. They have Zoho CRM used by its internal employees. Now they needed, Zoho, of course, is a SaaS, is a software as a service, purchased on the cloud. Outside the premises of the bank. Zoho needs to send information to the fintech application whenever, for instance, a profile of a certain employee gets updated. What to do here? To us as a system, Zoho is another application that needs to communicate with our system. Then, introducing a backend for frontend specific to this CRM can be a good idea. What we did, we have implemented IP whitelisting, only letting request incoming from the IP range given by Zoho to pass through our infrastructure. As we're gonna see next, Zoho has its own authentication mechanism. It can be implemented here as well on this layer. Imagine Team A having to deal with adding a or communicating who is responsible just for the web UI, the desktop UI, must have a concern about how Zoho has to communicate with our backend service. No, even the mobile team has nothing to do with that. Nothing should affect Team C handling or delivering its features, serving its clients. That is a concern that has to be handled on the back end, guys. I'm not saying you must have a specific team for that, but this kind of stuff can be handled using the backend for front end pattern. Zoho backend for front can communicate with several backend services. You see here this backend service is dealing with a cloud file storage, Google Cloud Storage, for instance. So that is another case beyond a desktop UI and iOS and Android frontends. Now, there is an important case here that we need to talk about last, is the combination of a gateway and a backend for frontend. What is a better decision here? Probably, I'm not sure if he's the inventor, but the creator of the book, the microservices book, Sam Newman. I'm sorry if I got his name wrong, but he advised for this approach, having a gateway layer or the gatekeeper pattern. If you watched that pattern previously in our collection or our security best practices course, the gatekeeper pattern impose a gateway layer at the front of our infrastructure before hitting our services or our backend for frontend. So Sam Newman recommend not having the backend for frontend and the mobile backend for frontend dealing with cross-cutting concerns like authorization or logging. I'm not sure what's his opinion about caching as well. So he always advocate for having a gateway that handles this kind of stuff. You see here, the gateway handles the authentication with Active Directory, plus logging into a central logging system that can be read through a dashboard here, Kibana or Grafana or whatever you are using. Now the web and the mobile here can go authenticate, or where they put their username and password, and then the token received from the Active Directory can be passed to the gateway all the way through your infrastructure. This way, the backend for front end is solely dedicated to handling logic related to the front end application. It has no concern related to authorization, authentication, and logging or caching or whatever. Just it can be translating the JSON or the response that can be a gRPC, by the way. Your backend service can provide a gRPC for better performance on the bandwidth side. They can transform that into a JSON file, for instance. Or the main reason is that they want to optimize, or actually here on the mobile side, optimize that JSON in order to be served all the way back to the mobile frontend. That is another case we have to consider when using this pattern. So always make sure when taking this decision that this additional layer, let's come back here, the additional layer you are adding needs to be carefully planned because you are adding a new service. This service needs to be maintained, needs to be production ready. You don't want this kind of layer to act as a single point of failure. You need to take care of its load balancing to the traffic there. So when to use this pattern, guys, to end? When you have different features or mobile features affecting the development on the back-end service of another in front end like a desktop UI. Features are intermingling with each other. When your back-end service is starting to have conditional logic to serve specific front end, that is when you know that you need this pattern. Another more important reason is your team organization. Again, the way your team communicate dictates your such architecture decision. Let each team handle its own stuff alone, on its own release cadence, its own priorities. That is productivity, guys. Now, why not to use this pattern, you may ask? Of course, when you have a single front end, this pattern does not make sense. So that's it, guys. See you next time.